So now here we have another circuit that I'm going to turn into shorts. So when I turn the overhead lamp off, when it gets dark enough, the blue LED lights up right there. And there should be a link on the short where you get the full video if you're not watching the actual full video. So what we got here is a 555 timer right there and a light dependent resistor. When the light dependent resistor gets enough light, it's preventing the reset pin from setting the output low. We always want the output high otherwise. A 1K resistor going to ground, you need a low value resistor to pull it to ground. We'll talk about that later. But in any case, the blue LED that we're lighting up, we got the long lead anode to the positive supply, short lead the cathode going to the resistor to the output of the 555 timer, and it lights up when the output goes low, connects to ground. And we will just take an easy look here at the schematic drawing that I took. So a 555 timer, I'm using the NE555. You could also use the Micro A555. And it's the integrated circuit. There's the pin layout. When it's a dual inline package, you work your way down 1 to 4 in this case. And when you get to the bottom, you jump across and work your way up with the numbering. And there's the pin names. But in any case, we got the 555. You got the input 2, wants to keep the output high. But input 4 can force the output low. We'll look at that later. And for the output, we got the blue LED. Since I got it to the positive supply, it's going to light up when the output is low. So now this isn't a terribly complex circuit. Again, when it gets dark enough, then the output goes low. The blue LED lights up. That's what the circuit does. But, you know, since this is a pretty simple circuit, we'll explain a couple things a little bit extra. So, of course, you always have to power the 555 timer there. Pin 8 VCC to the positive supply right there. Pin number 1 is the ground pin right there. Pretty straightforward. So on the breadboard here, I have pin 8 to the positive supply. Also, you can share other stuff. This is a direct connection to the positive supply. Doesn't matter if these components connect to that row or to one of the other, be over there, one of the other positives. But yeah, negative right there. Power's coming from the alligator clips, and there you can see when it gets dark enough, the blue LED lights up. And then jumpers connect the two rails together so that both rails are definitely the same power supply. So now, coming back to the circuit, again, when it's dark enough, in this case, the blue LED lights up, output goes low. One of the main things is we got pin number 2. So I just have a jumper connecting pin number 2 to ground. You could use a resistor as well. We just need to hold the voltage down. We never have a positive supply voltage going to it, so we don't have to worry about too much current anywhere. So we can make a direct connection to ground, but you could use a resistor as well. So, in any case, pin number 2, when it gets a low input, it wants to hold the output high, but pin number 4 is more powerful. So even though pin number 2 is always telling the output to go high, whether it actually goes high or not depends on pin 4. So pin 4 is the reset pin. Pin 2 is the trigger pin. And you can see that over here. We have a gray jumper to the negative supply. I try to color code the jumpers, but the color of the jumper does not matter. It's where it's connection. It's the pin 2 right there. So now coming back to the schematic, as we mentioned, to get the output to go low, blue LED light up, we need to get the light dependent resistor dark enough. And so now we're going to talk about that part of the circuit, the reset pin. So there you can see, written up there. Reset. So it's more powerful than pin 2, which is always trying to hold the output high, the way that it's wired up right there. Pin number 4, though, we need a low input, very close to ground, to make the output go low, to force it low. That's reset. So we got the light dependent resistor. When a fair amount is falling on it, like there is now, it keeps the voltage up, away from ground quite a bit. So pin number 4 is not doing anything. We get dark enough, though, there you can see that path right there. It pulls the voltage down. And then pin 4 resets the 555 timer, as you can see right there. We covered that. We got a better connection to ground, 1K resistor to ground, and light dependent resistor to the positive supply. So now to wrap up this video and shorts series, we have the output right here. Pin number 3 when it's the 555 timer, and the blue LED. So you can see we got it headed to the positive supply right there. You got to wire the blue LED in the right way. Any LED, short lead the cathode needs to be headed towards the more positive supply. So when the output goes low, the blue LED will light up. I have 220 ohm resistor there. Usually I use 1K, but that's what I wrote on there for whatever reason. Probably because I copied the amount of resistance I was using with the red LED in the similar circuit. But there you can see we got positive supply. Of course, the blue LED, the long lead, the anode, has to be towards the more positive. Short lead, the cathode, towards the more negative when it lights up, as you can see right there. So with this circuit, we have to get it dark enough before the LED will light up, either with my finger or turning the lamp. So that's about it for this circuit.